Ever get this feeling like the universe is kind of like playing a giant game of Tetris, constantly shifting, rearranging itself?
I like that.
We usually think about tiny particles, the building blocks, right?
Yeah.
Well, today's deep dive, we're looking at this paper. It's called In Search of the Last Turtle, Toward a New Physics of Inequality.
Okay.
And it's suggesting that maybe, just maybe, it's not these tiny particles that are the foundation of everything, but something totally different.
All right. I'm intrigued. What's this paper proposing?
Inequalities.
Interesting. So, for centuries, physics has kind of operated on this idea. We call it the Platonic paradigm.
Yeah.
Basically, the universe is like this giant, super complex Lego set.
Right. With all the pieces fitting together perfectly.
Exactly. Protons, neutrons, electrons, the whole shebang.
Like that classic image of an atom we all saw in high school science class.
Precisely. But here's the thing. Like a Lego set that's missing a few pieces, this framework, it doesn't quite explain everything.
Right.
We've got mysteries like dark matter or the whole strangeness of quantum mechanics. Those don't really fit neatly into this picture.
They don't. So where do these inequalities come into play?
Well, that's where things get really interesting, actually. This paper, it's proposing a pretty radical shift.
Okay.
What if, instead of matter being the fundamental driving force, it's actually the interplay of inequalities that makes the universe tick?
Okay, hold on. We need to unpack that a bit. We're not talking about economic inequalities here.
No, not exactly. No, think of it more like a cosmic dance, in a way. Differences in energy levels, temperature gradients, even the interplay of supply and demand.
Right.
These disparities, they create this kind of cosmic tension, and it's this tension that actually sets everything in motion.
So it's less about things being equal and more about the universe constantly trying to find that equilibrium, that balance.
You got it. In the paper, it actually calls these movements towards equilibrium inequality choreographies.
Inequality choreographies.
Ah.
Okay? That sounds kind of intriguing, but I need a visual. Help me understand, what does that actually look like in practice?
All right. Picture a diagram. At the starting point, you have your inequality. Let's say a difference in temperature between 2 points. Now, this difference, it naturally wants to resolve itself, right?
Sure, yeah.
And in doing so, it triggers a kind of division of tasks. Think about like specialized workers in a factory,
Okay.
each playing a specific role to achieve a common goal.
Right.
In this case, that goal is resolving that temperature imbalance.
I see. So instead of every part of the system trying to do the same thing, you get specialized roles that emerge in response to the inequality itself. That's a really different way of looking at it.
Exactly. And here's where it gets even cooler, right?
Yeah.
As these tasks, they start to evolve, they become incredibly intricate, intertwined, almost like the steps in a really complex dance.
Oh.
And it's this intricate dance of interactions that ultimately leads to those stable patterns, those structures we see in the universe, from galaxies to planets to the elements themselves.
So it's almost like the universe is choreographing itself into existence
Yes.
through this interplay of inequalities.
Yes.
Always pushing towards resolution, towards balance.
That's a great way to put it.
And what's amazing is that this whole process, this cosmic dance, it actually follows a really fundamental principle in physics.
It does.
It's called the principle of least action.
Right.
Okay, I gotta admit, that name, it doesn't exactly scream like mind-blowing cosmic principle at first glance.
Right.
So what's the principle of least action all about?
At its core, it means that the universe, in a sense, prefers to take the most efficient path. Any system, whether it's light traveling through space or these inequality choreographies playing out, they naturally gravitate towards the state that requires the least expenditure of energy.
So it's less about the universe being lazy and more about it being incredibly efficient, always opting for that path of least resistance. It makes you wonder how this principle plays out on such a grand scale and what it means for our understanding of how the universe really functions. I have to say, this is definitely challenging my preconceived notions about, well, pretty much everything.
Yeah, it's fascinating stuff, isn't it?
So we've got this cosmic dance of inequalities constantly pushing towards balance, shaping the universe as we know it. It's a lot to wrap your head around. It really makes you think about everything being in motion, always responding and shifting. Where does machine learning come into all of this? Because the paper mentioned it was key to really understanding these choreographies.
Right, and it's interesting because Think about how we traditionally approach physics. We use equations, models, trying to describe the behavior of individual particles, those forces.
Mm.
Machine learning, it takes a totally different approach.
Yeah, how so?
Imagine you're looking down at a bustling city from above. A traditional physicist, they might try to understand this city by analyzing the movement of every single car, every pedestrian.
Okay, I see.
Machine learning, on the other hand, it would be looking at the larger patterns of traffic flow,
Right.
identifying rush hours, those bottlenecks, like kind of the ebb and flow of movement throughout the day.
So instead of getting caught up in all the tiny details, machine learning is looking for those bigger picture patterns,
Yeah.
right? The trends that emerge from like the complex interactions, all those individual parts.
Exactly. And this is so powerful when we're talking about these inequality choreographies because machine learning algorithms, they can sift through these massive data sets, astronomical observations, particle physics experiments,
Right.
and they're able to pick out these really subtle patterns, these correlations in the data that our human brains, they might just totally miss.
Right.
It's like machine learning can see the underlying choreography,
Wow.
the flow of these inequalities in a way we just can't.
It's almost like it's giving us a new set of eyes, this whole new way of perceiving the universe that goes beyond our traditional methods. It can be hard to wrap your head around because it is such a different approach. What kind of patterns is machine learning already picking up on? What's it actually revealing about these inequality choreographies?
Okay, so one of the most striking examples that the paper talks about is the prediction of gravitational density patterns.
Okay.
Traditionally, these have been mapped out using these complex equations derived from, like, Einstein's theory of general relativity.
Yeah.
But what's fascinating is that machine learning algorithms, they've been able to predict these same patterns without relying on those equations at all.
So they're essentially bypassing like our current understanding of gravity or established physics and getting to those same conclusions just by analyzing the data, by looking for
Yeah.
those patterns of inequality.
Exactly. And this is really profound because it suggests that these inequality choreographies, these movements towards equilibrium, they might be even more fundamental than we realize.
Right.
They could be the underlying principle that governs even the force of gravity itself.
Wow. That's a pretty radical concept that something as fundamental as gravity could be a result of this dance of inequalities.
Yeah.
Definitely a different way of thinking about the universe than we're used to.
Yeah.
This idea of inequality choreographies, it seems like it can be applied on such a vast scale.
Mm.
What about those really extreme environments in the universe? How does this model work when you're talking about something like, say, a black hole? Black holes, that they're still, I mean, kind of these big question marks, right? It's
Yeah.
challenging everything.
Yeah.
To think about them through this lens of inequality choreographies, it's pretty wild.
It is. It is. Imagine a black hole, not just as this region of extreme gravity, but
Yeah.
like this point, this ultimate cosmic imbalance, where the fabric of space-time itself, it gets like stretched and warped
Wow.
because of this, just immense concentration of inequalities.
So if this inequality model is right, then a black hole, it's not really about a singularity at all.
Right.
It's about this like maelstrom of disparities, right?
Yeah.
This massive tug of war of forces all trying to find that balance.
Precisely. And because black holes, they represent this extreme environment,
Yeah.
they're kind of a perfect testing ground for this theory. Because by studying how matter and energy behave around a black hole, we might actually get a glimpse of these inequality choreographies
Right.
at work in their most extreme form.
It makes you realize that this whole concept of inequality choreographies, it's not just some abstract like mathematical idea. It could totally change how we understand the most extreme objects in the universe, right?
Absolutely. And maybe not just distant objects either. Think about it. It might even hold the key to understanding the very essence of reality itself.
Okay.
Our perception of a stable universe, it could be kind of an illusion. What if instead, imagine a reality that's in constant flux, this perpetual dance of inequalities driving everything.
That's a pretty profound thought. It really makes you question, I don't know, everything you thought you knew about the universe.
Yeah.
From the smallest particles to the biggest structures, it's all connected through this intricate web of inequalities.
It's all connected. And this is, like you said, this is just the beginning of exploring this. This inequality choreographies idea is still, it's in its infancy.
Yeah.
But it really has the potential to, like, revolutionize how we understand physics, maybe even lead to new technologies. Who knows?
So if our listeners are like, their minds are blown, they want to go deeper, what are some key takeaways from today's deep dive?
Okay, so first, remember, the universe, It might not just be about particles. This interplay of inequalities could be even more important.
Yeah.
Second, machine learning, it's becoming crucial here. It's allowing us to perceive these inequality choreographies in ways we just couldn't before.
Right.
And lastly, this whole new perspective, it really challenges us to rethink everything.
Yeah.
Gravity, black holes, you name it. The universe, it might be a lot more chaotic, a lot more lively than we ever imagined.
It really gives a whole new meaning to that phrase, keeping it real, because it turns out reality itself might just be this constant balancing act, this never-ending dance of inequalities shaping the cosmos as we know it. This has been quite the journey. So until next time, keep looking up, keep asking those questions, and remember, there's always more to discover on The Deep Dive.